Before 1977, the consensus on the outer solar system was bleak. Past Mars, scientists assumed we would find little more than a cold, dark void populated by frozen, cratered rocks. Astronomers noticed a ticking clock. Jupiter, Saturn, Uranus, and Neptune were drifting into a rare alignment on one side of the Sun, happening once every 176 years. This opened a temporary window. A spacecraft could use the gravity of one planet to slingshot to the next, cutting travel time to Neptune from 30 years to just 12. To catch this window, NASA built the twin Voyager spacecraft. These probes ran on early 1970s technology, powered by the heat of decaying plutonium. They were hurled into a freezing, radiation-filled vacuum on a one-way trip, with no return trajectory and no possibility of rescue. Voyager was our first attempt to cross the physical boundary of the space between the stars. Voyager 1 reached Jupiter first, navigating through intense, deadly radiation belts to gather its data. Almost immediately, the probe captured active volcanic plumes erupting on Jupiter's moon Io. Until that moment, astronomers assumed all moons were completely inert. The energy driving these volcanoes comes from a process called tidal heating. Jupiter's immense gravity acts like a vice, physically squeezing and stretching the moon. All that friction melts the rock from the inside out. Nearby, Europa offered a different surprise. Voyager mapped a surface covered in intersecting ice cracks, providing the first scientific evidence of a hidden liquid water ocean beneath the crust. Looking back toward the Sun, the probe's cameras even detected a thin, faint, dark ring system circling Jupiter, proving that Saturn was not the only planet with rings. In a matter of days, Jupiter's moons were revealed as dynamic, active worlds with their own internal engines, forcing scientists to rethink how planetary systems operate. Pushing deeper into the dark, the spacecraft approached Saturn. High-resolution imagery proved Saturn's rings were not solid disks, but thousands of individual ringlets. Their sharp edges are carved by tiny shepherd moons orbiting the gaps, while electromagnetic spokes sweep across the icy dust. To study Saturn's largest moon, Titan, scientists made a strategic sacrifice. They intentionally altered Voyager 1's trajectory for a close flyby, a maneuver that permanently threw the probe out of the planetary plane. That sacrifice paid off. The probe found Titan shrouded in a thick orange haze, concealing a dense, nitrogen-rich atmosphere incredibly similar to early Earth. By the time the probes left Saturn, they had proven the outer solar system was a chaotic laboratory of electromagnetic forces and complex planetary chemistry. With Voyager 1 heading up and out of the solar plane, Voyager 2 continued alone toward Uranus and Neptune, entering a region where sunlight is incredibly weak. Capturing images in near-total darkness required engineering miracles. Scientists back on Earth had to rewrite the probe's software mid-flight for long-exposure photography without motion blur. At Uranus, Voyager 2 discovered 10 previously unknown moons and a pitch-black ring system that was completely invisible from Earth. During its final planetary encounter with Neptune, the probe captured the Great Dark Spot Storm and photographed the moon Triton, actively erupting freezing cryovolcanoes. Human ingenuity kept a fragile machine alive across billions of miles, revealing that even the coldest edges of our solar system are geologically active. On February 14, 1990, Mission Control commanded Voyager 1 to turn its cameras back toward the inner solar system one last time. It captured the iconic pale blue dot photograph. In that iconic image, Earth appeared as nothing more than a fraction of a pixel, suspended in a scattered sunbeam. Decades later, in 2012 and 2018, the twin probes were still traveling outward, their sensors waiting for a specific shift in the surrounding vacuum. This chart shows exactly what they found. The yellow line represents solar wind particles, which suddenly dropped to near zero. At the exact same time, the blue line, representing high-energy galactic cosmic rays, spiked 40-fold at a boundary called the heliopause. That data confirmed the probes had pierced the Sun's protective bubble, officially entering the interstellar medium. Bolted to the side of each spacecraft is a gold-plated phonograph record. It carries greetings, music, and sounds from Earth, a message in a bottle for any intelligence that might eventually find it. Today, despite failing power supplies and degrading components, engineers back on Earth are still coaxing data from these silent probes. By mapping the gas giants and pushing past them, these probes extended our presence into the galaxy, marking our first permanent steps away from